All right. Good morning, folks. As I said, thanks so much for joining us for today's Database in Memory Office Hours. My name is Maria Colgan. I'll be here to help answer questions that may come in via the Q&A option, which is one of the buttons at the bottom of your screen. Joining me today is Andy Rivenes, who will be our presenter. Andy, I'm going to hand it over to you.
Great. Thanks, Maria. So I'm a product manager for Database in Memory. We've done many of these sessions on our AskTOM webpage. Not only do you see today's session, but previous sessions, and then here, and then also, oh, did our resources go away? Oh, there they are. And then resources if you have questions afterwards. So our blog, some of our white papers, access to the YouTube channel. So if you have questions afterwards, you can go there. Obviously, you can email me as well if you want. I have my email on our presentation. And with that, I think I'll close this and we'll get started. We'll do it this way. Seems to be easier to navigate. And what we did, actually, I'd forgotten. We've done so many of these AskTOM sessions. I did a RAC session back last year with Mike Gleason. We talked a little bit about some of the ways that RAC works. So what I thought would be fun to do, based on some questions we've had recently, is to kind of go through the architecture and how it works with Database in Memory, works with RAC, and some examples. We'll actually run, I've been fortunate enough to have a RAC, 3-node RAC system that we can demonstrate on. It's actually running 19C. So it makes it a lot more fun to be able to see how Database in Memory actually works on RAC as opposed to just talking about it with slides. So we'll do a little bit of architecture, and then I'll show you some kind of how you populate, how distribution works, which is kind of the reason for the architecture overview. And then we'll run a couple queries, show you, we'll talk a little bit about parallelization. And then we'll talk a little bit about how you can use the for service option, which has also come up recently with several customers, to isolate or to populate objects on specific nodes if, for instance, you need to use application affinity, because both EBS and actually SAP as well don't let inter-node or cross-node parallelism work. So very often for those customers, they need to isolate objects to specific nodes in order to be able to use Database in Memory with RAC in their environment. So it's actually something very useful and much simpler than it was when we first came out with Database in Memory. So with that, I've got 2 monitors here. I'll hopefully be able to talk to you, but I still have to be able to see what I'm doing here. So safe harbor statement, but let's real quickly kind of go over our introductory information and then a little bit of architecture on Database in Memory. So again, our dual format Database in Memory works as part of Oracle Database. We have our traditional row store, and then Database in Memory adds a new column store and allows us to populate objects that always exist in the row store into columnar format in the column store. And that's what gives us, for analytic queries, a significant speed up in performance. Analytics, being able to scan and filter large amounts of data very, very quickly in columnar format. And so that's kind of the secret sauce of Database in Memory. Very simple to set up. Well, the in-memory underscore size parameter is an initialization parameter. On RAC, you have this on each instance, and a single instance, it's just one. So we actually, in RAC, will have multiple instances or multiple column stores, which is where we get into the conversation about distribution and parallelism. Kind of the point for today. Very simple to alter a table in memory. Actually, we support tables, partition, subpartition, and materialized views. And then the analytic index thing, since Database in Memory accesses objects with a table access in memory full, we don't use indexes. Doesn't mean you can drop all of your indexes, but typically your analytic reporting indexes you can eliminate, since typically Database in Memory won't use them, and the optimizer, if it's choosing an in-memory plan, then there's no point in having those indexes. There is a relatively there's a cost to maintaining those indexes, and of course they take up disk space, recovery, redo, undo and redo, and so it can be very advantageous to drop those analytic reporting indexes if you're not using them. So that's kind of the story there, which we've talked about in previous sessions.
So Andy, quick question on that.
Yeah, already, okay.
I know, so hopefully you may already be covering this later on, but does the in-memory size parameter need to be the same on all RAC nodes?
Actually, it doesn't. And if we hold that question, we'll talk a little bit about why you probably do want to have that the same, but it's possible to have them different. So,
all right,
yes.
Cool. Yeah, we can come back to it.
We'll see if we can kind of cover why you might or might not do that, depending on what you're populating and where you're populating it.
Okay, sounds good.
What's that?
Sounds good.
Okay. The column store, when you set the in-memory underscore size parameter, the column store is allocated this in-memory area here, this red area, as part of the SGA. So we've kind of talked about not stealing memory from other areas like your buffer cache, your shared pool, and allocating additional memory in the SGA and then to the column store to allow you to populate these objects in columnar format. But that's kind of the architecture within Oracle Database in the SGA, as we allocate the column store or the in-memory area within the SGA. So we're fully integrated in Oracle Database. It's not some add-on that we've created. It's the optimizer understands that objects are populated in the column store. Where all of the existing Oracle syntax and operations still work the same. You still can say show SGA or select star from $SGA and see how much memory is allocated to the column store as well as to other pools, some of which I've listed here in the column store in the SGA. So very just kind of architecturally how database and memory works within Oracle Database. Then within the in-memory area, we allocate two pools, which we'll actually I'll show you when we talk about the in-memory area or the $V in-memory area that shows that, is there's a 1 meg pool and a 64K pool. As you can see, the area on the left is what we call IMCUs, which we'll talk about in a minute. And then the area on the right is what we call metadata or snapshot metadata units, SMUs. Not that you have to know anything about any of that, but the 1 meg pool are the IMCUs and the 64K pool is the metadata. You can't change any of that. It's all done for you automatically. It's just kind of an architectural thing so you kind of understand how database and memory works and what you're looking at when you see some of the views, so you can determine how much space you're using and what objects are populated. So really just kind of background information for you. With that, when you do populate an object, in this case our employee table, an object will be made up of one or more IMCUs, which will come out of the 1 megabyte pool in the in-memory area. And so each of those IMCUs will be made up of one or more 1 megabyte extents. And so depending on how large the object is, and we're going to talk a little bit about this because of the implications for RAC, your table, depending on how big, could be one or more IMCUs made up of one or more 1 megabyte extents. And then each of those IMCUs will have one or more SMUs associated with it. There are actually another form of something called IMEUs, not to make things complicated, but if you're using in-memory expressions, you can actually see IMEUs as well. There are some $V views to display that, which we'll actually take a brief look at just so that we can kind of determine how large or how many IMCUs make up our segments that we're going to populate in our RAC environment. And the last one, which is a little newer slide I put together, because this is going to come into some, it will be part of our discussions, is that, I'll have some tables in our star schema benchmark that are small and some that are large. And so when we look at the objects populated, there may be some, at least I had questions, you may have questions. And so this is some more background. Question would be, how big is an IMCU? So if you said, well, you populate an object made up of one or more IMCUs, well, when do I go to 2, 3, 4 IMCUs? And this becomes interesting when we talk about distribution within RAC. And so what I have is here kind of a little bit of an overview and a query, and I'll show you a magnified version, and then we'll look at it actually in C++ and RAC. That roughly with the default compression level, we get an IMCU is about 500,000 rows before we start to create a second IMCU. So it's size-based. It's actually more technical than that, but it's easier just to remember that it's about 500,000 rows. And what I have is on my next slide, my fancy magnifier, which kind of works, is since the script here is pretty hard to see, notice that each of these IMCUs, which is what this IMCU address is about 500,000, a little over 500,000 rows. And so that's kind of the threshold at the default compression level. At higher compression levels, it changes, but for our purposes, I just wanted to point out that in IMCU, you won't just have, there is a algorithm to determine how many IMCUs an object will be made up of. And this again will come into play or become more interesting when I show you some C++ screens here in a second. So
Andy, we have
yes.
2 questions,
Okay.
slightly related to what you're talking about, some from a little earlier. The first question is, if I have a database configured for a mixed mode, so OLTP as well as real-time analytics, or OLAC type operations, then would it be wise to still have indexes for faster OLTP access on some of the columns that may also be populated in the column store?
Yeah, I usually tell folks kind of the easiest way to think about it is that obviously any kind of constraint definitions, we have primary keys, foreign keys, anything enforced by an index, those indexes you're going to keep. Any indexes where you might be doing lookups, where you're not actually looking at very many rows, index access is probably going to be faster. Remember, this is always a cost-based decision, so it's the optimizer that's going to decide based on how many rows, the cardinality, how many rows it thinks are going to be returned. What is the cost lower to access that data through an index or through a in-memory column? Table access in memory fold, accessing that data through the column store. And so, like a lot of things with DBAs, the answer is it depends. And basically, there's a couple of ways to tackle that problem, but the short answer is that you very likely might need still to have non-constraint indexes for lookups and for OLTP type access where you're only going after a very small number of rows. And so then an index access is going to be faster than scanning the entire object's columns or columns to access that through in-memory. Now, with that said, the threshold, depending on the size of the object, the threshold can be pretty low. And we also have things we've talked about like in-memory storage indexes where we can prune out IMCUs, effectively acting like an index. So it's not cut and dried whether or not you're going to need indexes. One of the things we've kind of said in the past is if you make the index invisible, run through a couple cycles of your business cycles, access some SQL Monitor Actor reports, see the performance of the queries, and you kind of have to determine, do the queries that I'm running make sense? Are they accessing those indexes, or can I not have them? So it's not cut and dry, but the answer is yes, you might still need you might still need indexes for OLTP type workload.
Yeah, and I think
I'm going to try to cut my answers down in length. But
no, but I think you nailed it. It is based on the cardinality, how many rows and how useful that index is on being very selective in returning a small number of rows. Right. I think you hit the nail on the head with that.
My long-winded version of it.
The second question that we got, although you haven't mentioned it, the question was about using database in memory on Exadata. And the question was, do I already have this in place on Exadata, and do I just have to identify the tables I want to go in memory, or am I still on the hook to do the setup? And I think this probably comes from the fact that we talk about having the in-memory format automatically on Exadata. If you want to perhaps address that, Andy.
Sure. So on Exadata, we do have actually two flavors of database memory. If you think about it, we still have what we've talked about here is the column store in DRAM within the SGA in Exadata would be on the compute nodes, but we also support database and memory formats on the storage servers in Flash. And so the automatic part is when database and memory is enabled on Exadata, we'll automatically, any objects that aren't populated in the column store in DRAM in the SGA that you haven't done an alter table command on, will be automatic, if they're smart scanned, will be automatically brought into the flash cache and reformatted into database and memory columnar format so that all subsequent accesses of that object will take advantage of all of the great features of database and memory. So that's completely automatic. You don't have to specify any objects. We'll do that completely automatically. So that would be like, even on ADW, we do that. And so that's fully supported on Flash. But in the column store part, we still have this conversation where you have to decide which objects to populate in the column store. Now, that said, we do have some new features because, again, we keep adding, we're really trying to make database and memory fairly automatic. So we have something called automatic in memory, which we introduced in 18C, which is in 19C, and we're going to release with the next version of Oracle when that happens with some even bigger enhancements so we're on the path to making even the DRAM fully automatic if you want it to be as far as what objects get populated. But even in 18C and 19C, you can, for objects that you've specified for no priority and that are in memory, we can automatically start to populate and evict segments from the column store based on usage. And so hopefully that kind of covers the two places where there might have been confusion.
All right, awesome. Thanks, Andy. I'll answer some of the other questions we got directly in the chat just to allow you to get on. We can always come back to those and discuss them live because I think you're going to hit on some of them as we go through the presentation.
Yeah. So anyway, so that only point of all this wasn't so much that you need to be able to run queries against, in this case, $IM header, but that an IMCU is a certain size, and then we'll create a new one. And so that was kind of the point of that. Again, getting back to the conversation about how we populate data in a RAC environment. So I'm going to talk about distribution next, but let's bring up and make sure all this is going to work okay. And I wanted to show you what I've currently set up. So I have a 3-node RAC environment running 19.7. And what I wanted to show you is, so I have, thought I put my connect string in there, I did not. Okay, so I have our typical SSV schema. Notice you can ignore this right now.
One quick request from the viewers. Can you make your font a little larger, please?
I can try, yeah. So I have more room on the screen here. So if you can't see it, I should have asked. Oops. See if we can make it even bigger. Either that I can go into, I can't.
No, it's definitely getting bigger.
It's hard to, because I can't.
There you go. That looks a lot better for me now. Okay, hopefully the folks on the chat, if that's okay for you now, just let me know.
Okay. Yeah, I don't know. Let's see. I guess I can. Yes, it's good enough.
People seem happy now.
So ignore this large part. I did that, and I'll talk about why. But this is our normal. Right here is our normal star schema benchmark. So I've loaded those tables into the database, and right now they're enabled for in-memory, and actually they're populated with the default compression level, kind of things we've seen before. So that's what we're going to start with our talking about how this works within a RAC database. So we have I have 3 nodes. Actually, I was going to run, well, we'll just do it this way. So notice that what I'm doing is actually I'm querying $GV IM segments rather than $V IM segments, since we're on RAC. And you notice you see the instance ID and then our segment. So most of the segments are, these two guys are dimension tables, if you will, that are relatively small, are all on instance ID 1. And I'll talk a little bit about why that is. And then the line order table, which is our fact table, which is relatively large, has been distributed across all 3 instances. So part of the line order tables populated in instance 1, then 2, and then 3. And that gives us scale out. So if you think about it, that's one of the great things about database in memory on RAC is that now you're not limited to the size of a column store on a single node, but you can use all of the nodes as part of a RAC cluster to create even a larger column store to access that data and have that data in memory. And we're going to talk a little about querying it, and I might want to pick up the pace a little bit, but anyway, so that's what we've got there. And then I'm going to skip around a little since I didn't have a lot of time to, it's kind of ad hoc, so bear with me. But so you might ask, well, how much memory do we have? So remember $GV in memory, or in memory underscore area. In our case, it will be $GV in memory underscore area. I can talk at the same time. And then you can see, normally we would just have our 1 meg and 64K pool on a single instance, but since we have 3 instances, now you get to see it on all 3 instances, and you can see that we have allocated, I think it's like 2,000 or 2 gigabytes, and part of that's taken up by, actually I think it increased it to 3 gigs. So part of that memory is allocated to the 1 meg pool, part to the 64K pool, and we can see how much memory we used within each of the 1 meg areas or the column stores for, so you know how much memory you have available to populate with. That's kind of the gist of that. So what I wanted to talk about, actually, now let's go back, let's run this last query. So I put together another query so based on, let's see. So based on our population here, right here, one might wonder, how come all of the dimension tables are on instance 1, and then we only distributed the line order table across the other instance, the 3 instances? So why aren't all of them distributed? And so in this particular case, I think it's somewhat interesting, but I asked that question, so I figured you guys might. And it's worth explaining. So I have a slightly different query I've run here. And what this does is, I guess I can show you, no hiding it. It's a little more complicated. I've combined some of the internal views, which you can query, $IM header, which shows us the breakdown of objects and how many IMCUs make up those objects, $IM segments, which we've already looked at, and then DBA objects so we can get a name. And I've run a query that basically shows now the same information, but notice if we go over to both the number of IMCUs, this column here, sorry, I'll do that. We see that our line order table has like a little over 150, 170 IMCUs that make up the size of the object that gets populated. So we've distributed those fairly evenly across the 3 nodes. But notice that our customer table, our date dimension table, our supplier table, and even the part table only has 2. They only have 1 IMCU. So how do you distribute a single IMCU across 3 nodes? It doesn't make sense, right? And that's why you're seeing that. So it's a special case in the sense that my schema isn't huge and those dimension tables are small. So I only wanted to point out that actually that's the reason that you see these guys, these small guys, not being distributed across all 3 nodes. Because you might initially think, well, wait a minute, it's like 202 gigabytes or 2 megabytes or whatever it is there, and why am I not getting distribution? Is there something broken? And so the answer is no. It doesn't make sense because we're always operating at the IMCU level. Just like in the row store, we operate at the block level. We do I/O at the block level. We don't do I/O at the row level. And in database and memory, we scan IMCUs for column values, but we don't scan individual column values, right? So just trying to, hopefully I didn't get too complicated with that. Maria's kind of looking like, oh, what are you,
no,
what are you doing?
I was just going to butt in and say, bear in mind that the data is compressed, and that might be why an object that's on disk,
sure,
like your customer's object there, that seems to be a lot bigger than 1 meg on disk. Why did it fit into 1 meg, IMCU in memory? And it's of course because of the compression.
Good point. Yeah, because remember I showed you in the attributes that we're using the default level of mem compress for query low, which generally is about a 2x compression level. But the bottom line is, we get to take advantage of compression when we put it in memory. And so, yeah, you're right. That makes it all fit in just one IMCU in essence, which is a good thing. So let me flip back. So let's talk a little bit about this idea of distribution. So the only reason I put this slide up here is because we're populating IMCUs. So we're going to read the data from the row store, we're converting into columnar format, it goes into an IMCU. When we hit roughly 500,000 rows, we're going to create a new IMCU. And so we get one or more IMCUs making up our objects. We can, database and memory on RAC can distribute, there's an automatic distribution mode, that's the default mode. So for tables, materialized views, we'll distribute by row ID range. For partitions, though, we can distribute by partition. We can distribute by, which means a partition will go on one column store, the next partition will go on the next column store, and we'll just distribute by partition, pretty simple to figure out. We can also distribute by subpartition. And then as we were looking at, we can distribute by row ID range. And the whole idea of this, if you think about it, is that we're looking to get as even a distribution across the column stores as possible. And we'll talk a little bit about why that's important, but that's basically what's going on here. And then you can display it, as we've already seen. I just have a little script here, which is basically just what we're seeing when we take a look at this here, the RAC IMSeg, which is just basically showing us how our objects are distributed. So now we're limited still by the architecture. So even though we're going to try to get as even a distribution across the column stores as possible, for very small objects, especially when there are only 1 or 2 IMCUs, typically they're just going to land in one instance. But as we get our larger objects, and again, in a real production environment, you're going to be probably talking about hundreds of gigabytes or even terabytes of data. These objects are going to distribute and look kind of like this one, the line order table does. And it's a fairly even distribution. So I think that covers what I wanted to cover there, because we're going to talk about access in a second. And then I had a couple other scripts that I wanted to run. So let's take a look.
So Andy, sorry to ask questions while you're typing, but
okay.
Just so that I'm telling the truth on the Q&A, you will share the scripts that you're using today on the blog if they're not already there, right? Or how can
these scripts aren't on? I'd be more than happy to share the scripts. Let's just put it that way. They're not currently there, but that's I'll put that down. So I have like our hands-on lab scripts that are out there. I will, and I think I have our other Ask Tom session. So I will be more than happy to put this on the blog. Be patient, it might take me a couple of days. Last time I said I'd have it the next day and it took me a week to get it out there. It wasn't entirely my fault. I still had to go through some of the Oracle bureaucracy, but I will get it there within the next few days. And I'll be more than happy to make these scripts available. There's nothing secret about them, and so more than happy to do that. So scripts on the blog.
All right, awesome. Thanks, Andy. Sorry to distract you.
No, that's fine. So what I'm going to do is I'm going to take that large part table, or it's actually the part table, not partition, but this part table here. I just made this table larger, and so I wanted to show just let me do it. We just alter it in memory. Let's kick off so we don't have to wait. Should pretty quick. So notice that the part table we have only populates. Remember, we displayed it only has one IMCU. I made it slightly larger, and now we see that it starts to distribute as it gets larger. Now it's distributed on 2 nodes. It's the same basic table. I just made it larger. I doubled it, or I maybe tripled in size. That table and my only point was to show then that the number of IMCUs then has grown. So now the large part table takes up a total of 5 IMCUs, and so now we've distributed that to 2 nodes. And as it would continue to grow, then it would probably grow large enough that we would distribute it to all 3 nodes in this case. And so the idea is we're using distribution to try to even out the space used by objects within the column store to give you the maximum benefit of the memory available. And so that was kind of the only point of my demo here, was just to show you that as the object goes from 1 IMCU and starts to grow, then it distributes across the different column stores, and we get into where we have something like the line order table, which is fairly evenly distributed across all 3 nodes. And that gives you the ability then to maximize a column store to the number of nodes that you have available, so you're not limited as you would be on a single instance to just the memory available in that node. And with that, we're good to go. So I'm actually going to have it here to take it out so it's not in our way. Remember, the nice thing about database and memory is you can alter something in memory, no in memory at any time, so you can have different objects based on different workloads, whatever. So we've altered it no in memory. And I did this just to make it simpler. So now we have our normal star schema benchmark. We're fully populated. We have our line order table and distributed across 3 nodes. Our our dimension tables on 1 node. So now the question becomes, how do we access that data? So let's talk a little bit about how that happens in RAC. So in a single instance node, we can run a serial query. All the data is in 1 column store and everything works fine. If you run a serial query on a RAC instance or a RAC database, cluster, in this case I have 4 instances, our demo's got 3, there's no way for me to run a query against this first node where the red dot is and access data across these other 3 nodes in memory. I can do it off of disk, but I can't access that data. There's no way in Oracle for a serial query to access memory from another instance of data in the SGA. So in the row store, we might do cache fusion. We might bring blocks back into the local nodes SGA and the buffer cache to access that data, but we can't do that with database and memory because we don't ship IMCUs across the interconnect. It's kind of, think about it as that's our scale out ability with our data here, is we're not going to ship then the data that's on nodes 2 and 3 over to node 1 so you can run the query. That would be very inefficient because that data, remember, is in 1 meg or larger extents. That's a lot of data to ship across the interconnect. So that's why we talk about the column store being essentially a shared nothing environment where that data is accessed on the nodes that it lives in or that it's formatted in. Hopefully that's clear. And so how do we get around that problem? Well, with database and memory, we have to use parallel queries so that we can access those. Do those slides look familiar, Maria? So that we can access the data on all 4 nodes, or in our case, all 3 nodes. And so we have to use parallel query to do that. And that's kind of one of the things that database and memory is very good at, is leveraging the other parts of Oracle database to give this great performance that we see from queries. And so parallel query, the optimizer, data guard, all the other features of Oracle database work and are part of how database and memory works. So anyways, the point of all this is that we use parallel query then to access the data on the other nodes to get that very fast performance. And that's what we're going to show you in a second. The only other thing that that implies is you have to have a DOP at least as great as the number of nodes. In this case, 4. In our demo, 3. And in 12.102, we had to have auto DOP enabled, but we changed that restriction so that you can actually set manual DOPs if you want, and it'll all still work. But the takeaway from all of this is really just that when you're in RAC and you have data distributed across different RAC nodes, so you can do scale out, you have to use parallel query. And I put, and the slides will be available, I put some of the key parameters around parallelism that customers use to adjust parallelism, because for a lot of DBAs, parallel is kind of a 4-letter word, but there are very straightforward ways to control with parallel query for use in a mixed workload environment. So that's kind of why I included that information. We have some other documents, white papers, and videos that talk about that a little bit. So I was just wanted to make sure that you were aware of that, so that you don't go out and wind up with a DOP of 128 and 2 queries try to run and you get inundated with CPU resources where you don't have to have that happen. So what I was going to do then is leave us with our next topic, and let's go take a look at how that actually works. So what I've got is 2 queries, and rather than type them, I'm going to cut and paste because I've already shown I'm not a great typist. But I have an in-memory query that will run serial. So I've tried something a little different from my normal scripts that I use. This is just a literally two table join, line order and date dimension. Remember, the line order is distributed against all 3 nodes, but the date dimension table only lives on instance ID 1. And I actually connected to DBIM, so I don't really know what instance I'm actually on, so we'll find out in a second. That took almost 20 seconds to run, kind of long. Oops. And I don't have to hit enter because I did it automatically. So I have a SQL Monitor report in text mode. I thought it would be easier to look at, so I don't have to display it in the active format. Notice it took 21 seconds of CPU time, and we did our table access in memory full against date dimension and line order. But if you notice this column and these guys, we did a whole bunch of I/O. So, and the reason for that is since we ran a serial query, depending on which node we started on, and I actually don't think, instance ID 2. So it does, I think this is actually a pretty, if you're going to do character-based, this is a pretty nice little format to use for demos. So we started on instance 2. So remember, we're looking at the line order table, this guy here, and the date dimension table. So if since we ran serial on instance 2, we actually were able to access this data in the column store, but the rest of the data, date dimension, and the other 2 line order pieces of the line order table, we had to get from the row store. So the query will run, but it runs slow. So let's take a look at how this works if we run it in parallel. So I'm going to cut and paste again because I don't want to type it. Whoa, 0.57. So we went from 20 seconds to half a second. So something happened. And so what happened? And what we can see is, and one of the other beauties of SQL Monitor reports is we see that, okay, now we're running parallel. We're running in parallel. And we're accessing, again, in memory, date dimension and a line order table. But now we start to see something a little different. So we're actually, the query ran, says instance ID 1. We know we're connected to 2. But notice now we don't have, the buffer gets, very low number of buffer gets. And we have our parallel instance section. So we ran parallel processes on all 3 instances. And that's how we were able to access the data fully in the column store and why it runs in only half a second. So I'm kind of glossing over a little bit of this because I don't want to spend too much time on it, but the bottom line is whether you use a SQL Monitor active report, a text version, something that shows you where time was spent, you can see that, oh, all of a sudden the reason this is so much faster is because I didn't have to do any I/O. I was able to access this data through the column store. Now, the other way to look at this is also with session stats. And so you can take a look at that as well. There's various ways in Oracle to take a look at this. But I thought this was kind of the easiest way to get the point across that we're running now parallel across all 3 nodes, and we're able to access all this data in the column store. You have something to say, Maria?
I do. No, just because questions are flying in, and I'm answering them, some of them via the chat or the Q&A, but there's one that what you're showing on the slide on the screen right now will answer the question perfectly. So the question is, in a RAC environment, will a parallel slave of one node be able to fetch data from memory on a different node?
So the answer would be no.
Right, and you're demoing it right there. Sorry.
That's right. And for the same reason that a serial query can. And so what happens is we run our parallel server processes. Notice, actually, it may be hard to see. Yeah, there it is. That I actually constrained this query, I'll show it to you in a second, so that the DOP would only be 3, rather than whatever the optimizer might have come up with, which could have been very large because it doesn't take into consideration concurrency. But so I purposely ran it as just a DOP of 3. We have 3 instances. And so we ran parallel query coordinate, or actually parallel query server processes on each of the 3 nodes. Our query coordinator ran on instance 1. And so what happened is then the results of each of the scans against the objects in the other column stores, just the results were then brought back to the query coordinator that put those column values together to then return our query, which was way back up here, and gave us the total revenue. And again, phenomenal number compared to 20 seconds. So in the exact same query. So hopefully that covers it.
Yeah, so really what you're saying is the query coordinator told the 3 parallel server processes, one on each of the nodes, what data they needed to access. And then they went ahead and ran their part of the query on their data and sent only the results back to the query coordinator over the interconnect. So it wasn't that a node was, or sorry, that a parallel server process was accessing memory on a different RAC node. Each process was effectively tied to a RAC node or started on a specific RAC node, and it only accessed the data on that RAC node and sent back the results.
Excellent, yes.
All right, but I love your script.
Much better than I probably said, so very good. Yeah, but exactly. That's Oracle architecture, right? So that's not anything to do actually with database and memory. That's how parallel query works. So yes. So that's one of the reasons it's great to have you here as well. So we have two ways of saying things, and maybe yours makes more sense than mine, but that's okay. So, and
I have the advantage of being in the cheap seats and listening to your answer first before I give mine. So yeah.
So the last thing I wanted to mention and talk a little bit about, because I did mention the fact that there are applications, EBS and SAP are 2 that come to mind, that don't allow you to use parallelization across instances. So all of a sudden now, this ability to do this distribution and access the line order table or access data on any of the column stores falls apart, because those particular applications, it has nothing to do with in-memory, it's just what their restrictions are just to run the application, say that you can only do parallelism within a single node. So all of a sudden, how do you deal with that? Because now if I've got my data distributed across nodes 2 and 3, I'm stuck because I can't access that data, so it's slow, so why use database and memory? Well, the great thing about database and memory is we keep adding features to allow customers to take advantage of it no matter what they're running. And in 12.2, we introduced this ability to do a distribute for service, or in essence, to tie population of an object to a specific service and therefore a specific node. We did this for 2 reasons. The main reason actually was for active data guard, so that you could determine, because you can't do an alter table on a standby, so you do alter table on the primary, and you can determine based on the service, do I populate an object on the primary, on the standby, or on both? So that's one of the main reasons for service, but also for this reason too. So we can determine now where we have population. So actually, this is I was gonna do a couple things. I was gonna show you that I'm gonna do a RAC command here real quick. just to show you what our services look like. And hopefully we won't run out of time. My goal is always to make these short, and we wind up having more to talk about. So what I've got is I've got a DBIM service that covers all 3 of our RAC nodes. And then I have a DBIM 1, 2, and 3 service that covers each. DBIM 1 is instance 1, 2, and 3. And then there's actually, by default, an Aura CL, but I put DBIM because it makes it clear for our demo purposes. So that's just RAC. That's how RAC operates, and we've set up services. So now database and memory can take advantage of that. So that was the point of showing that. So let's connect back in. And what I wanted to do was, remember we have our line order table distributed across all 3 nodes. Let's take it out of memory. And we can just, I don't actually have that in my script, but we're going to alter it a little. And now it's gone. So now let's do something like, if I get all of the, now the priority isn't required, but I do it so that it'll automatically be populated. I up the compression only because I don't have tons of disk or RAM space, so I want to get it fully populated, so I'm going to compress it to a higher level. You don't have to do this in your environment if you plan for it, but mem compress, whoops. Just for demo purposes. So we use our highest level of compression, and I gotta bring my, so make sure I get the syntax right. And then we're gonna say distribute for service, and we're gonna put it on DBIM 2. So notice that that matches the service we saw here. And let's make sure we kick it off as fast as possible so you guys don't want to leave me before we get it. That'll take a second. So now effectively what I've done is I've said I want the line order table, I want the line order table to only live on node 2. So maybe node 2, maybe this is for an application, I don't know, maybe we're doing purchase orders or something for EBS, or maybe we're doing some kind of inventory application where we want the line order table and any other associated tables. We want that application's only going to be able to run from a single node. We've picked node 2. So we're going to populate objects only on node 2. We're going to connect to node 2. So now we don't have to worry about running parallel across other nodes because all of our data is going to be isolated to the node we're connecting to. And remember, I showed you in the previous screens and the slides that we can only access data in the column store. Now, obviously, the row store is different. We can access data anywhere. The row store, we do cache fusion. That's great in RAC. But in the column store, we can only access that data on the node we're on unless we use parallel query. So even if we use parallel query, if we've segregated our application to only running on node 2, then all that data needs to be populated on node 2. So what I've effectively done then is said, we're going to distribute for service to DBIM 2. So in theory, our line order table will be populated fully on node 2, and so far so good. I don't know if it's still, it's still populating. So I do it again, we see it going down. And I know it's going to fit because I did compression high, so I just kind of wanted to show the demo of it being fully populated. But that's what the force service can allow and support then for things like EBS and SAP. Much simpler than the way it worked in 12.102. This is 12.2, 18C, 19C in the future. And so it makes it very simple if you do need to subset nodes. I didn't want to get into a big conversation about how all that works other than just showing the facility. You actually have to know a whole lot other than knowing that now I can run an application on a single node if I can't use either parallelism or parallelism across other nodes. So is that relatively clear, do you think, Maria?
Yeah, and actually ties in really nicely with a question that I was just answering in the Q&A, which is if I had a serial query in your original demo where if I was connected to node 1, the dimension table, so the customer table, the part table, supplier, they were all on node 1, but only part of the line order table was on node 1. And they were saying, if I issued a serial query from node 1, what would happen? And I think your distribute for service would help in that case. But I don't know whether you want to just quickly go over that, just so folks are clear.
Yeah, so that, well, okay, so that's one of the things you learn when, if I did this demo again, then I would have actually chosen to populate the line order table on node 1, which would have been smarter. I didn't think about it, to be honest. I was just kind of finding a place to stick it where there was as much space as possible without regards to that, because all the other objects are on node 1, and I didn't have unlimited memory. But the serial query we ran that ran in 20 seconds, you're right, if that query, if line order and date dimension were both on node 1, then this query would have run just as fast as the parallel, regardless, ignoring the extra CPU that gets dumped into having multiple, splitting that table up in 3 and being able to access, or the advantage of parallel query itself. But the bottom line is it would have accessed all that data through the column store, and I could demo that right now had I been smart enough to put this on node 1. And again, the reason I just picked node 2 was because I wasn't sure I had enough space with all these other objects. I had to fit it in to fit onto the node. Notice bytes not populated to 0. So now line order is fully populated on the node 2. And so if I had been smarter and put it on node 1, we could run the query, and it would show that, yeah, now you don't have to run parallel, you can run serial. So you can access, because all that data is local. So I will change this demo, I guess, if I do it again, which I probably will, so that I'm smarter about it. But I wasn't thinking. So
no. I mean, it's just it kind of paired in nicely now that you've shown the for service. Very quickly before we go, there was one other question in the chat that I'd love for you to hit on, because it'll allow us to advertise the fact that these sessions are recorded. The question was, is database in memory an additionally licensed option?
Well, as you well know, yeah, it is. Database in memory is an option. So in Oracle speak, an option, which options are part of Enterprise Edition, so not Standard Edition, but Enterprise Edition. An option, it is, you do have to, it's chargeable. You have to pay to license database in memory. If you go back and look at our blog post, though, you'll see that we also now have in the 20C pre-release moving forward, and we're actually in the process of backporting to the July. What we're hoping, we're not. Don't hold my feet to the fire, but our plan is to release with the July 19C RU the base level feature in 19C as well, which will allow you to use 16 gigabytes, allocate a 16 gigabyte column store. And in a RAC environment like we have here, you get 16 gigabytes on each of the, in this case, 3 instances, whereas you can actually take advantage of database in memory and not have to license it. So there's this, what we're calling the base level feature. I have a blog post that I did just a few weeks ago. You can go take a look at our blog, which is right there. That URL, and you can take a look at that. So yes, the full database in memory option is you have to license, but it is possible moving forward to use something we call the base level feature, whereas you get 16 gigabytes and you don't have to pay for it, other than Oracle Database Enterprise Edition.
All right, no, that's a good point. I'm quickly putting the blog URL into my answer.
Okay, yeah.
Updating my answer.
Actually, that's the resources page. The regular blog is just that guy right there, which obviously you know, but for other folks. So if you want to go look at that post, And that's actually really exciting. I think it's going to really make allow people to see the real value of database and memory. So I'm really excited about it. But hopefully that kind of gives you a flavor of how database and memory works on RAC. Again, it went way longer than I thought it was going to go, but I think it showed the highlights of what I was interested in showing folks. And we did have a bunch of questions. Hopefully those got answered.
Yeah, worst case, I can answer this one offline, but in the 2 minutes that we have left in the office hours, can you quickly explain what happens if an instance crashes and with an IMC, with the in-memory column store on that instance?
Sure. So if instance 1 crashes, then obviously all of the data in the column store on that instance won't be there. That's the in-memory part of in-memory computing. And so depending on how long that instance is down, so if it goes down and you run a query, obviously any of the data that you're accessing in your query that was populated on that node will have to get from the row store, so it'll be slower. If that node stays down for it's about 5 minutes-ish, then if there's room on the surviving nodes, in our case, node 2 and 3, we'll automatically repopulate that data into those nodes. So either through distribution or however, it'll act as if it's just a 2-node RAC cluster. And then happy path, you're great, and you run, and then if that node comes back up, then we'll redistribute data so that it's fairly even again. Whether or not the single guys move or not, they probably won't, but at least the line order table, if it was back to where we distributed it, it would even it out. So we'd make use, remember we're trying to make as even use of the column stores as possible, and so that would be happy path. On Exadata, you can duplicate, and so that's a whole nother conversation, but you can mirror and avoid some of those issues if you're on Exadata, so just a point of information.
Okay, and with that, we've hit the top of the hour. So I will let you go, Andy. Awesome job. And thanks so much to everybody who attended and for the great Q&A. You kept me on my toes and busy typing throughout. So thanks so much for all that interaction. And we look forward to seeing you again next month on another AskTOM Office Hours for Database and Memory.
Great. Thank you, everybody.